Right, so yesterday with the heating curve, we talked about how states of matter change with temperature, and today we're going to talk a little bit about temperature, but we're also going to look at how pressure and volume affect states of matter. So if we look at these two pictures, going from the picture on the left to the picture on the right, the volume is decreasing, which is also causing the pressure to go up because the molecules have less places to move, so they're going to collide with the walls of the container more frequently. So if you have the pressure is increasing, we know from this picture that the volume is decreasing. And as the volume decreases, you can see the particles are becoming on the right much closer together. And so if the particles are becoming closer together, that's going to lend itself more towards the characteristics of a solid. And then the opposite would be true. If I go from the picture on the right to the picture on the left, we are increasing the volume of the container, which is decreasing the pressure, allowing the particles to have much more space to move around and allows the particles to spread out a little bit more, which will then be more characteristics of a gas. All right, so I'm going to talk about a little bit of this today. We're going to get into a lot more about pressure and volume tomorrow when we talk about gas laws, but this is going to help you understand phase diagrams. So pressure, by definition, is the force exerted on a container. So the more frequently particles hit the walls of the container, the greater the force they exert when they hit a container, the higher the pressure. Pressure, there are a bunch of different units of pressure. These are the four that we're going to talk about the most in here. You have millimeters of mercury and torr, atmospheres, and kilopascals. The one we're going to talk about today the most in these phase diagrams that I'm about to teach you is atmospheres. We'll talk about the other ones later on. And the other thing that I am going to just briefly mention today, we'll go into more detail tomorrow, but is this condition called standard pressure and temperature, or STP. If I tell you that I have something that's at standard temperature and pressure, that is just me telling you that it's at 0 degrees Celsius or 273 Kelvin, or it's at one of these four pressures. And again, we'll talk about more about that tomorrow, but I just wanted to introduce it here, and we'll do volume later on. All right, so the last thing you're going to learn today is these phase diagrams. And phase diagrams look at the relationship between pressure and temperature and how that affects the state of matter. There are a couple points that I'll show you on a phase diagram, but before I do that, I want to tell you what their definition is. So the triple point is the point at which a particular substance is a solid, liquid, and a gas. So it's the temperature and the pressure where all three states of matter coexist. All right, if I pull up this video, now the sound is not going to work, so let me just fast forward. So they have some water in here with some boiling chips. Let's see if I just fast forward a little bit. So if you look at this now, you can see the water's boiling, so that's one state of matter. You can see right here in the bottom is a solid, so that's the second state of matter. And then the vast majority underneath here is the liquid. So this particular substance is at its triple point. It's at whatever temperature and pressure it needs to be for a solid, liquid, and a gas to exist at the same time. All right, let me head back to the notes. So that's the triple point. The critical point is a point where no matter how much pressure is exerted on a container or on a substance, it can no longer be liquefied. And the next vocabulary term that you need to be aware of when it comes to phase diagrams is the normal melting point or the normal boiling point. We already talked about yesterday what a melting point is, so that's the transition from a solid to a liquid, and boiling is from a liquid to a gas, but normal is the new part. So whenever in chemistry you see the word normal, that refers to the pressure is being 1 atmosphere. And so with the normal melting point, it's the melting temperature of a substance when the pressure is 1 atmosphere. And then a normal boiling point would be the similar idea. So it's the boiling temperature of a substance when the pressure is 1 atmosphere. And I'm going to show you where all 4 of these points would be on a phase diagram. This is a phase diagram, and you can see that the y-axis is the pressure. In this case, it's atmospheres. And the x-axis, I think the unit's cut off a little bit, but it's temperature in degrees Celsius. And so phase diagrams look at the relationship between pressure and temperature and how that affects the state of matter. All phase diagrams are going to look the same. The lines might have different slopes, but they all generally follow this exact same pattern where it's just one line and then at some point it splits off into the 2. So before I go over some example questions that you might be asked about a phase diagram, I want to label all the different points. So on a phase diagram, regardless of the substance that it's talking about, this first section on the left is always going to be a solid. The middle section is a liquid. And this bottom section here is a gas. The phase changes happen on each of these lines. So if we're going from a solid to a liquid, so as soon as you cross over this vertical line here, we transition from a solid to a liquid, which would be melting. If you're going in the opposite direction from a liquid to a solid, that would be freezing. We talked about these phase changes yesterday. This line right here in between liquid and gas, if you are transitioning from a liquid to a gas in this direction, that would be any one of the terms we talked about, so boiling, evaporation, or vaporization. If we go in the opposite direction, so from a gas to a liquid, that would be condensation. And then this line here in between the solid and a gas. So now the phase diagram or the heating curves yesterday did not show this transition between a solid and a gas, but the phase diagrams do. So if we are transitioning directly from a solid to a gas, that is sublimation. And directly from a gas to a solid is deposition. Now the other points that you need to be aware of, this point right here in the middle is the triple point. We talked about that on the last slide. And this point up here in the upper right corner is the critical point. So here are some questions that you could be asked relating to the phase diagram. So the first one says, what is the normal boiling temperature of this substance? So remember, normal means 1 atmosphere. So I'm going to go here on the y-axis and find 1 atmosphere. Boiling, I know, happens between a liquid and a gas, so that's going to be on our line in between liquid and gas. So I'm going to go from 1 atmosphere of pressure, and I'm going to do this all the way over to this boiling line. And then if I just go and read the temperature, it's at about 400 degrees. So I would say that my normal boiling temperature is 400 degrees Celsius. What is the normal freezing temperature of this substance? So freezing, again, is between solid and a liquid, or going from a liquid to a solid. So I would go, again, at 1 atmosphere because it's normal to that line. And then I would go down to the temperature, and it's about 100 degrees. So the freezing point of this temperature, the normal freezing temperature of the substance is 100 degrees. Another question I could ask you is, what state of matter would you have if the substance was heated to 650 degrees at a pressure of 1.5 atmospheres. So this is me essentially giving you the x coordinate and the y coordinate, and you just need to figure out at which place they meet. So a temperature of 650 degrees would be about here, and a pressure of 1.5 atmospheres would be here. And I'm just going to take those two lines and figure out where they meet. And they meet about here, which would be in the liquid region. So the state of matter would be a liquid. And the final question, the final type of question I could ask you is, at a constant pressure of 0.5 atmospheres, what phase change would occur if the temperature was increased from negative 200 degrees to positive 200 degrees? So I'm at a pressure of 0.5 atmospheres, so I'm here. And the temperature, it says you start at negative 200 degrees, and I'm keeping that pressure at 0.5, but I'm going to increase the temperature to right about there, which is 200 degrees. And so as I increase the temperature, your substance is going to go from a solid to a gas. And if I ask you for the phase change, I want you to use the words that we talked about yesterday. So don't say from a solid to a gas. Use the term that we talked about, which is in this case would be sublimation. So those are 4 types of questions that I could ask you about phase diagrams. You will have some practice later on in class using the phase diagram and reading it. And that's it for phase diagrams.